All right, questions 8 and 9 on 3.5. So it says first thing we need to do is graph the functions where we've got x squared minus 4, x minus 1 quantity squared minus 4. So let's go ahead and just graph those. X squared is just going to be our parent parabola function, so at 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. There's our parent parabola function right there. And we also had x squared minus 4, so that'll be our next function where it has just been moved down 4 points, or 4. Got over 1 up 1, over 2 up 4, over 2 up 4, over 3 up 9. So there's our second. And the last one, h of x, where we have moved our vertex to the right 1, because remember we changed the sign, and down 4. So now I've got this last function here, to the right 1, down 4, and over 1 up 1, over 2 up 4. And so on. There we go. So now let's answer some of these questions. How do the functions compare to each other? Well, they're all the same parabola. They don't have any stretch. They've just moved where the vertex of that parabola is. So the same thing is true of g of x and h of x. They compare to f of x in the same way. They're the same basic parabola shape, but they've just moved downward 4, and h of x moved to down 4 into the right 1. So we can just include all that information under b and c. Then looking at d, look back at the functions above and identify the x-intercepts of g of x. So if we look at g of x, the x-intercepts are at -2 and 2. So that's our first step. We've got -2, 0, and 2, 0. Then it says, what are the coordinates of the points corresponding to the x-intercepts of g of x in each of the other functions, and how do these coordinates compare to each other? So we look just at -2 and 2, and up here in our original function, we've got those points that are just up 4, right? And then, let's see, if we were to continue this h of x function, that green function all the way up, it would have been over 3 and up 9. So that would have actually been right here. Oops. And over here it would have been right there. So that function is there. And we can see that our x-intercepts of the green function, h of x, or the value at the x-intercept of the blue function, is at -2, +5. And then over here we've got +2, -3. So for our green function, what actually happened is we've got some varying values, right? Because the parabolas go so much more steeply. So for our green function, for our x-intercept of the blue function, it is up 5 from where our x-intercept is. And at +2, it's down 3 from where our x-intercept is. So it's almost as if it's exactly as if we would have just shifted everything over to the right one to get our green function. And then for our red function compared to our blue function, the f of x compared to the g of x, those values are just up 4 from where from where the blue function has moved down. So we can say something to that effect. H of x moved all points to the right one, all points of g of x to the right one. We could also say f of x, or h of x, no, f of x is all points of g of x up 4. Alright, so this last one is actually pretty neat. So if we were to look at our function up above, our parent function, which is just the x squared, but then to look at our general case of a times x minus h quantity squared plus k, and this is the vertex form that we've seen many times here. If we're to look at this, we can actually use that vertex form to show us what the new x-intercepts are, and they're going to actually be this kind of similar to how we've looked at the axis of symmetry. The axis of symmetry is positive h, right, because it's just the x value of the vertex. But then what we can also know is that the x-intercepts are actually going to be plus or minus, h plus or minus the square root of negative k. So we had where h was positive 1 here. If we did plus or minus the square root of negative 4, or of minus a negative 4, which is positive 4, we get 1 plus 2 and 1 minus 2, which tells us that our x-intercepts are at 3 and negative 1. And we look over at our green function, and that's right where they are. So this little formula is how we can get our x-intercepts.